Hello everyone, in this video I am going to explain about this BuildZri project which we initiated recently in our GitHub organization. So this is basically a minimal build automation tool for C++. So very first maybe I can mention about build automation tool. So if we are going to compile some C++ project, assume that you are going to create a small hello world program. So in that case we can directly use the compiler CLI interface, right? I assume that you have the GNU C++ plus compiler installed in your computer, installed in your Linux computer. Then we can use this G++ CLI command, right? So this offers various CLI options, like if you provide this help flag, we can see all supported CLI options. So using this syntax you can compile C++ programs, right? But if you use this approach for compiling your C++ project, there are several problems, right? So very first, before discussing about those problems, then let's check how we can use this G++ thing for compilation. So we can provide the file like this. Assume that you are going to compile main.cpp, then after that you can provide the O flag, and then you can mention the output file name. So this is the else binary that will be created eventually by the G++ compiler, right? Here we can provide main. So then if you provide this command, then the main.cpp C++ will be compiled into binary code and will be written into this main binary, right? So that's how basically this G++ works. So then assume that you are going to use this G++ for compiling a large project. Then you need to provide various file names, right? Main.cpp, then again another file, maybe a.a1.cpp, then a2.cpp, then maybe there you need to provide some additional flags as well for optimizing build, and also maybe you need to provide some macro definitions as well. Using this -d option you can provide some macro definitions, right? Like if you use dtest equals 1, then inside the program you can use this test macro definition, right, in your C++ program. So if you use this kind of approach for compiling C++ projects, if you have very large or maybe medium size C++ project, so then it will complicate the work, right? Because all the time you need to write this one and compile, right? And that's why we need build automation tools. So what is the minimal way to construct some kind of build automation for G++ maybe? So basic approach is to write some kind of shell script, right? Then if we check the neutral.js source code, then maybe if you jump into a version like 4.3, then you will see some build automations based on shell scripts, right? So we have build Linux, build macOS, and this is a batch script for Windows for building the binaries on Windows. So that's how we initially handle builds, right, in the neutral.js framework. Like I mentioned before, we didn't use this direct command, but we automated the thing here. If you check this build Linux file, for example, then if you inspect the source code, then you will notice the exact command I wrote here. So that's how we automated initially. We directly invoked this command within a shell script, right? So before triggering that G++ binary, then we did several configurations. We constructed the output file name, and then we provided the output file name here, right? This is the output file name. Then eventually we checked whether this compilation was successful or not. So just by checking the existence of that binary, then we handled things like that. So if there's a kind of compilation failure, then we exit from the process with some kind of non-zero error code indicating this process was had some failure, right? Then in our GitHub actions also, then it is detected by this exit code. Then we can see there's some kind of compilation failure. So that's how we initially handled this build automations. If you check the Windows batch script also, then you can see the exact thing, but in a kind of different way, right? We are triggering here the CLEXE also known as that MSVC compiler on Windows. Then before triggering that compiler, unlike Linux and macOS, we need to do several configuration, right? We need to configure the MSVC compiler for the provided architecture and stuff like that. Then after the configuration, then we can directly trigger the CLEXE, right? Then the syntax is little bit different, as you can see here. The macro definitions are different. These CLI flags are different compared to the G++, right? So that's how we handled automation, the build automation for new technologies in past days, using these shell scripts and batch scripts on Windows, right? This had a little bit drawback for us because we are maintaining several files. We are maintaining one file for Linux, one file for macOS, so on, right? We can see the macOS file also. There are some similarities, right? We can merge this one, this batch script with this one, maybe using some conditionals, using this with this one, this build Linux one, using some conditionals. Maybe we can rename this build Linux into maybe build underscore Unix and put both codes in one file. So we had several ways to simplify this one, but even though we did some kind of thing, but we have two files, right? We did Windows and build Unix. If we merge these two into one, then also we had a problem because we need to maintain two files here for build automation. And also if we need to add several things like additional things like maybe fetching the commit and adding into the build, something like that, then it is not very easy with bash, right? You know, bash is kind of a command language, right? Not a kind of dynamic and easy language to handle data and process data. And also on the other hand, in Windows also, in Windows batch scripts, handling data and stuff like that is a little bit hard, right? Compared to the language like Python and JavaScript. So we decided to do some kind of improvement to our build automation system. So we checked several tools like CMake, a very popular tool like CMake and other popular build automation tools, but in there also we saw several problems, right? So if we integrate such a tool like CMake into this project, so this project is not very large one, so we understood that it will complicate our source code, right? There will be some CMake list everywhere in the code base, so there will be some issues with the CMake and other build automation tools, right? So we needed some kind of very minimal way to handle our build automation rather than keeping two files for Windows and Unix. Then we needed some kind of one configuration file, but we didn't want to add some complicated syntax like CMake and other tools like. So we needed very minimal abstraction for build automation, some kind of cross-platform build automation system, right? So we created this BuildZri project as a solution for our problem. So we created this one. This is a very minimal build automation system that you can use for building binaries locally and on CI/CD servers as well. Also, there are very impressive features with this project. So the first thing is that everything in this build automation tool is defined with the JSON file. So you don't need to learn any other syntax for defining the configuration options. So everything is in a simple JSON file. So you can define your configuration using JSON keys and values. It is very easy, and also this will support GNU C++ on Linux and Clang or Apple compiler on macOS systems, and also MSVC on Windows. So those compilers are supported. In other words, this tool can be used for building cross-platform software, right? Also, this is written in Python. You can port this tool into any other operating system except this officially supported platforms. Then also like I mentioned before, this is very friendly for both developers and CI/CD servers, right? So this doesn't require any installation like CMake and other tools. So this is very simple script that you can copy paste into your projects. In this documentation you can see some sample configuration as well here. So if you check the source code of this BuildZri project, you can go to the source code by clicking on this link. So you can see one example project. So this example project is exactly this root level source code. So here we have the main.cpp and some code, C++ code, and also some other files like add cpp, add h, like those things are there, and the project is compiled using the BuildZri project. Here is the BuildZri configuration. We define configuration in this file, exactly in this file, buildZri.config.json. This is basically a JSON file like I mentioned before. Then you can define the build configuration here. According to this configuration, BuildZri will generate binaries, right? To become more familiar with this BuildZri configuration, now we are going to create very small hello world program using C++, and we are going to compile it using BuildZri. Now we are going to create a very small program. So I am in this directory. So if I open this one, so I am in this directory. We have scripts directory, like I mentioned. We can copy paste this BuildZri project, right? If you are going to create a project using BuildZri, you don't need to install anything. So this is very portable. You can just copy paste this file, bz.py file. You can download that file from this source code, this repository inside this scripts directory. So here is the place we added this bz.py file. So you can download this file. So this is basically the source code of the BuildZri project. You can download this script and copy paste into your script directory. We usually use this script directory for storing scripts. So inside this script directory you can copy paste this source file, right? Now we can execute this one directly using the terminal. Looks like I need to open this file manager in background. Now I'm going to close it and reopen it. Now here I'm going to compile example C++ project using BuildZri. Very first I am going to create one file called main.cpp. Here I'm going to write the source code of my project. So I'm going to open my favorite editor now to write this program. So here I am going to write very small program, right? Just hello world program, just to demonstrate BuildZri. So here I am going to write very small hello world program just to demonstrate how we can work with BuildZri automation tool. So now I am going to write this file. So imported IO stream, then I am going to use namespace std, then the main function. I'm just going to show something, maybe hello BuildZri. Now our hello world program is complete. Now I am going to create the BuildZri configuration file. You need to use this exact file name. So the file name is buildZri.config.json. Now I am going to edit this configuration. So this is the configuration file. So before editing this one, I am going to have a quick look into this example configuration. So this is one example configuration. So here we need to provide the C++ version, then the project name, then the version string, and after that the target file, the target binary file name, and then the source files, and also definitions if you need. So right now I am going to add these things here. Very first I am going to define the C++ version. So the C++ version is, I am going to use 17. So next I am going to use the name for the project, so maybe hello world. So next I am going to provide the version. So this is the first version, very first version. Then after that we need to provide the output as well. So right now I am not going to use this global variable. So these are known as global variables. So if you use these global variables before the compilation, it will replace the BuildZri system will replace these variables with actual values. So if you these things are dynamically replaced. So BZOS means the operating system name. So if you compile your project using this kind of thing, so then you will get the current operating system name in the binary name instead of this BZOS. You will get the current operating system name. So right now I am not going to use this global variables, but very first I am going to use some simple name. But after compiling this one, now I am going to use this kind of a global variable. So now I am going to define the output file name. So maybe I am going to use main as the file name. There's a special thing about this output file name, so you don't need to provide exe here. So if you provide main on Windows platform, the BuildZri automation tool will automatically add the exe thing into the output file name. So on Linux and macOS systems it will be like main, but on Windows system it will automatically add exe at the end. So the file name, output file name will be main.exe, right? So now I am going to use main. So after that we need to define the source file list. So here you can provide a list of source files, so maybe you can use kind of wildcard characters as well to include multiple source files at once. There's some kind of special syntax behind this source, so you can learn more about this source in this reference documentation. So if you check the source, the document says that you can provide glob syntax as well. So Python offers some kind of wildcard syntax to capture more file names. For example, if inside the API directory, if you have several directories, and inside each directory if you have several C++ source files, then you can use this single line, single file name to capture all the source files, right? So this will be expanded into several file names. So if you have several file names inside each directory, inside the API parent directory, right? So that works like that. You can check more details from this Python official documentation about glob syntax. Right now, since I have one single C++ source file, I'm going to directly use it like this. So if you have single file, you can use like this, just providing the file name. There's another special thing about this source, and also with other configuration options like definitions and options like that. So in here we can provide asterisk sign as a key. So inside so all the file names inside this asterisk sign will be included in all operating systems. So if you compile your project and provide source files like this in all operating systems, if you build your project, then those files will be included, right? So if you need to include some Windows specific source files, then you can provide this Windows key and the file list. Then if you have some macOS specific files, then you can provide those things via this Darwin key, right? Similar for Linux as well. Linux only source files will be included with this Linux key. Right now I am going to use this asterisk sign because in all operating systems I need to compile this main.cpp file, right? So this is some kind of cross-platform source code, right? So I am going to use source key here and going to define my source list using asterisk sign because I need to compile this source file in all operating systems, right? In kind of cross-platform way. So next with this asterisk key I am going to provide the file list. File list is just basically a JSON array. I am going to provide the file list like this. My file list only has this main.cpp because I need to compile one single file, right? This is the only one I need to compile. So if you have multiple files, you can provide like this. And also, like I mentioned before, you can use wildcard characters as well, and you can include multiple files at once. Now I'm going to use main.cpp only, right, because I only have this main.cpp source file. Let's check that sample configuration again. So here's the sample configuration. So here we can provide the definitions as well. Definitions are some kind of a macro definition, right? So if you need to define some value, maybe dynamically or statically on operating systems, then you can provide those values where the definitions key. The definitions key also accepts that asterisk sign and also the other keys like Linux, Darwin, Windows, likewise for cross-platform builds, right? So if you need to provide some kind of definition for all operating systems, then you can use this asterisk sign, right? So on Windows, Linux, and so on, you will get this macro definition into the source file, right? So if you have some maybe Windows is specific or Linux is specific macro definition, then you can use that specific key here, right? Like Linux, Windows, Darwin, likewise you can use the specific key here and define the macro definition, right? So now I am going to use maybe one simple definition here. I'm going to use a simple definitions, and I'm going to provide maybe I can use here. I'm going to use asterisk sign because I need to include this macro definition in all operating systems, right? So I'm going to provide all definitions here as a JSON array. So here I am going to provide the definition. Definition has some key value like syntax, right? So first you can provide the key, maybe like this test value, and also you can separate the key and value using the equal sign. So test value equals maybe 10. So this value will be defined on all operating systems using all supported compilers, right? So now we can use this value inside the main.cpp file, right? So let's compile this project without this test value. Right now I'm not going to use this test value because I just need to test whether this is working fine, right? Now I'm going to compile it. So how we can compile this one? Here I'm not going to use the direct G++ command, so any other CMake like build automation tool, because we have already a build automation tool, right? We have BuildZri, right? Now I am going to directly run the script. So the script will fetch this build configuration, then it will compile the source file using the GNU G++ compiler on Linux, right? On other compilers on other operating systems. Now I am going to trigger the script. So I'm going to explain this source file a little bit after this demonstration. So the source code is very simple and straightforward. So this is very minimal build automation tool, right? So we have a small source code for the build automation tool implementation. So I'm going to explain this one a little bit after the demonstration. Right now I'm going to execute this one. So here's the important thing: we have this shebang line, right? So if we have this line here, then we can directly execute this file on terminal, right? So now I'm going to execute this one. So we have the build automation tool configuration here, and we have the script. Now I'm going to execute this build automation tool script. So I'm going to execute it using like this kind of command. So inside the scripts directory we have bz.py. So now I'm going to execute this one. Compiling hello world, the project name we provided in the configuration. So it says that the project is compiled into main. So if you check the directory, we have main, right? The main binary. Now I'm going to execute it. So here we can see the hello world, the hello BuildZri message. Let's use this value also. So I'm going to extend this code a little bit by taking this test value also. Maybe I can print in another line. So I'm going to take this value, right? This macro definition, it is test value. So it is automatically defined into the preprocessor, right? We can directly use it now here. So test value, line ending is added. Now I'm going to recompile it. I just need to run the other command I entered. I just need to run the script. Now it is compiled. Now I'm going to run it. Now it works, right? So let's change this one a little bit. Maybe we can provide 1000. So it works, right? So it works, but how? We can check how it works. So how this value is sent into the C++ source file. So before I mentioned, we can use that -d syntax to provide the macro definition, right? So if you check the documentation of BuildZri in the reference, you can see some supported CLI arguments. We have only one right now, but we are going to add some other command line arguments as well, like just for triggering some kind of debug build. Likewise, we are going to add some other command line arguments as well. So right now we have verbose. We can provide verbose here. So if we provide verbose, then it will print some additional things, additional information about the build. So if you provide like this, then we can see which command is executed. So internally it will execute G++ and the version we provided in the configuration, and the source file list here. And here is the thing, here is the macro definition we provided, then the output is main. So it works like that. You can see the underlying command using this verbose flag. On Windows also you can see the command, on macOS also. So it's this one will work with any operating system, any supported operating system. So now I am going to explain a little bit about the supported global variables, right? So global variable documentation is here. So global variables are supported in these keys. We have output, definition, option like keys. So in there we can provide global variables. We can use global variables, right? So now I am going to use maybe BuildZri here. So it will print Linux on Linux and Mac on macOS operating systems, and also Win on Windows, right? So it can be used to easily configure the dynamically change the file name, right? The output value. So I'm going to use the global variable here, this global variable BuildZri. So global variables are having some JavaScript like template syntax. So I'm going to use maybe main dash the operating system name using this global variable syntax. So we can provide $sign, and after that we can, inside the curly braces, we can provide the global variable identifier, right? So the global variable is BuildZri. Now we can compile it, we can recompile it, right, without the verbose flag. Maybe we don't now we know what is happening, right, with the verbose flag. Now you can see here, right, the file name is main Linux right now. So if we ls, we have main, the previous one, but now we have main Linux. So if you compile this program on Windows, so the file name will be main win, main dash win. And also you can use the CPU architecture as well, and also you can use version and all global variables with this output thing, right, output definition. We can use the global variables with output, definitions, and options configuration keys, right? So we already use with output. And I'm going to use BZ version and also the architecture, CPU architecture name as well, using BZ arch. So I'm going to use those two here. So maybe like this, I'm going to use BZ arch here, and I can use maybe the version as well, right? So all done. Now I'm going to compile it. Now the file name is different, right? We have main dash Linux and the CPU architecture name and also the version. So that's how you can dynamically change the file name on each operating system, right? So this is very helpful when you are working with cross-platform builds. For example, if you check the Neutron.js repository, then in each release we are releasing different binaries, right? For each operating system and for each CPU architecture, we are compiling binaries, right? So we generate those binaries using BuildZri project. So if you check the configuration, the BuildZri configuration of the Neutrino.js project by inspecting this BuildZri configuration file here, so you can learn all things. So if we check the configuration, so according to this syntax, we are creating all binaries, right? All binaries on each operating system and each supported architecture, right? So here is our source file list. So on all operating systems, we are including this framework source files and also some libraries as well, right? So we use this blob syntax like I mentioned. So we don't need to provide all files here. We can easily include all files using this syntax, right? So on Linux we are including special some special libraries, right? So library source files, then on Darwin so on like that. So options are just additional CLI argument for the compiler program. So these are for size optimizations, right? So on GNU C compiler, we can provide some flags and optimize the size. Then these things are provided, right? To enable threading, we use this pthread flag, and after that we use this package config output also to generate some flags for including these some required libraries. Likewise, there are some configurations done using this options key, right? So on Windows also there are some configuration, right? So this is for size optimization, right? Also some frameworks are loaded on macOS, right? For the Apple compiler, Apple C compiler. And here also we can use global variables like this, right? And definitions are provided. These are just macro definitions, right? You can provide global variables also here, right? So this bz version is provided, right? So we provide the version into the source file like this, and inside the source file we use it. So if you check the settings.cpp and if you check the NL version thing, so NL version macro definition is used. So it is used to define this NL version JavaScript variable, right? So if you check the configuration back, so if you check the configuration, the NL version is provided, right? NL version is this one. So NL commit is also provided using this bz commit, right? So if we check the documentation, bz commit means the latest commit, right? So we can fetch the latest commit using this bz commit thing. Maybe I can demonstrate that as well. So if I need to fetch the latest commit as maybe like project commit macro definition, so like this. So if I need to take it like this, I can change the configuration like this. So the macro definition is project commit, right? So in the definition I can provide like this. So project commit is bz commit, right? But this should be some kind of string, right? But we need to escape it. But internally we for the G++ also this should be escaped, right? So I need to use the backslash twice, right? Now I'm going to compile it. So bz commit is provided to here as a project commit and to here, right? So I'm going to recompile it. So I got some JSON decoding issue. So issue is that I think I need to escape this one as well, this backslash. So now it should work. Now it is compiled, right? Now I can run this file. So main Linux and x64 like that. So if I run this one, so here I have the latest commit information, right? Now I can verify it. Now I can use this git command. So those things are equal, right? So it works. So this is the latest commit, right? So we can get the commit information like that, right? So that's how we define the NL commit. So if we check the internal source code of this settings .cpp in new technologies, then we can see nl commit, right? So commit is extracted like that. This is the current commit, right? Using this way we can identify the current code snapshot when the binary is built, right? So that's the very basic demonstration of this BuildZri project. So here I demonstrated how you can use BuildZri in your C++ project. So this is very simple example, but you can have multiple files as well, right? Multiple source files and multiple header files, just like any other C++ project. You can have multiple files, and you can use this BuildZri configuration to enable build automation with BuildZri project, right? So you can use this BuildZri with some medium size C++ project, right? So for example, we use BuildZri for new technologies. We actually created this BuildZri project especially for this new technologies project. Like I mentioned before, earlier we needed a way to simplify our build automation solution, which was based on the shell scripting and batch scripting. So it was a little bit different to maintain those shell scripts, right? There were like different shell scripts. So right now we only have this build configuration here, right? This is the only thing we have related to build configuration. So this handle all the hard things, right? So we have this script, but this is a different project, right? We have this BZ script, but this is a kind of a different project, right? So if we have new version, we can just copy paste the new version into here, right? That's how we can update BZ version. You can also check the BuildZri version using this Python global variable BZ version. So here we define the BuildZri script version, right? So that's how basically you can use the new BuildZri project in your C++ based project. Now I'm going to quickly explain this source code a bit. So after studying the source code, we can finally check how we can use the BuildZri project in CI/CD server, right? So we typically use this BuildZri project in Node.js with GitHub Action. So I'm going to show the source files of our workflows and how we can trigger BuildZri from GitHub Actions, like, right? First we can inspect the source code and quickly understand how it works, right? So this is the BuildZri script. So in other words, the source code of the BuildZri project. So if you go down a bit, we can find the entry point of the file. So entry point of the this script. So very first we open the configuration file, this BuildZri configuration file. After that we show some SKR. So just a simple SKR with the BuildZri version, right? So the BZ version is defined here, like I mentioned. So this is the BuildZri version, right? So after printing that simple SKR, then we are going to load the configuration into this C object after decoding the JSON into some kind of Python based dictionary, right? So using this C dictionary, we can get each configuration key and value, like the information, right? So now the configuration is loaded into this C object. So after that we are going to build the compiler command, right? Like I mentioned before, if you use the verbose flag, so if you use the verbose flag, you can see the underlying command, right? The compiler command. So this will be different according to the operating system, right? Right now I got G++ and syntax like that because I executed this BuildZri script on Linux, right? So if you run this one on Windows, you will get CLEXE and other things, some additional setup as well. Like I will mention those additional setup here about Windows, but just notice that this command will be different according to the operating system, right? So right now we are going to build the compiler command. Finally we are going to trigger compiling. This doesn't actually compile something here. I mean we are not going to pass source files and compile here, but instead we are going to trigger the compiler here, right? Compiler process will be triggered from this function. This is basically some kind of abstraction layer on top of actual compilers, right? This is not actually a compiler because this is kind of way to automate the compiling process in a cross-platform way, right? So we can quickly check the build compiler command. So if this is the source code. So on Windows we need to do some additional configuration, right? So before triggering the compiler, before invoking the compiler process, we need to do some configuration according to the CPU architecture and stuff like that. So if you check this configure vs tools, it is basically configuring the Visual Studio tools. Here we very first get the vsphere.exe path, and then we are going to find the Visual Studio path, and we are going to trigger this batch file, this batch script, and going to configure a little bit based on CPU architecture, right? So that's basically a small configuration only on Windows platform. So after the configuration, we are going to continue constructing the command. We are going to get compiler. So compiler will be different based on the operating system, right? So on Linux it is G++, on Windows CL, likewise, right? On Darwin or on macOS it will be like Apple LLVM compiler, right? So that's how the compiler is constructed. Then we are going to add the C++ version based on the configuration, right? Then we are going to include header file directories, right? After that we are going to add source files. Then we are going to add definitions, options, and finally we are going to add the target. So if we check the get target function source here, right? So this is the definition, right? So this will be different on Unix and Windows, right? So if you check the source here, you will notice out file equals get target name. So if you check the target name definition, so here on Windows we are going to append exe, right? So and also the global variables are supported, right? So apply template was means here we are going to apply global variables, right? We support BZOS and BZ version, all supported global variables are defined here, right? So in the get target name we are going to add exe on Windows and just plain file name on Unix, right? Unix and other operating system. So after constructing the command, now we are going to compile finally, right? So finally we are going to trigger the compile function, right? So we are going to provide the command. So command is already constructed, right? Just the compiler command. Then now we are going to run it, right? Using the subprocess modules call function, right? According to the command output, now we are going to display some output. So if the exit code was 0, then we know the process was successfully completed, right? The binary is successfully compiled. Then we are going to show this one OK message or error message, and finally we are going to exit from the process. So that's how basically this BuildZri project is implemented. Now we are going to learn how this BuildZri project can be integrated with CI/CD frameworks or CI/CD environment. So if you check the new technologies workflows, so all the workflows can be found in this .github directory. So this is the .github directory. So if we go there, then inside this workflows directory you will find all workflows related to new technologies DevOps related activities, right? So this is the one we use for creating a release, right? So if you need to create a new release, then I typically go to this actions tab. Then I'm going to select this create a release, right? Here I'm going to add the version number here, just like this. So next I'm going to click this button, right? So then the workflow is triggered. Then all the release process will be activated. So after the release process, then it will automatically produce a GitHub release, right? Finally it will send some message to Discord-sales. So that's how our release process works, right? So if you go back to the workflows directory, then if you check this create release, so if I need to create a release, so this workflow will be triggered. So if we check the build step, right? So here is the build step. So we are running this BZPY file, right? We are just compiling binaries, right? On CI/CD servers also, if you need to compile, you can just run this one. Just run this BuildZri script, right? So it will compile binaries. So on Linux, we are using some strategy, the matrix strategy. So we are compiling for x64 architectures and also ARM64 architectures and also ARM HF architectures as well. So for all architectures, we are just running this BZ5 file, right? Internally, this architecture will be added using a global variable, right? So the file name will be different, right, on each CPU architecture and each operating system. So if we check the final step, in the final step we are creating the release, right? We are creating the release zip and we are uploading into the GitHub, right? Into the GitHub release. So before this create release steps, we are going to execute all build steps, right? We are going to build binaries on Linux and for each architecture, CPU architectures, and on Windows also we are going to build, right? So in each step, if you carefully check, in each step we are uploading generated binaries into kind of temporary location, right? So using this upload artifact action, we are going to upload each generated binary into some kind of shared location, right? Because this each step is executed on different containers, GitHub Actions containers. We need to upload these binaries into kind of shared location, right? So now we are uploading each binary into kind of shared location. Then we are going to fetch each, right? Fetch each in this create release step. We are going to download each artifact. For example, here we are going to download Linux x64 binary, and we are going to download ARM64 binary as well for Linux, and so on for other operating systems and architecture. So as you can see here, we generated all binaries using just one command, right? We are going to just trigger this command. So depending on each operating system and CPU architecture, the BuildZri project will generate binary file names automatically, right? So that's why we got each binary in a different file name, right? Not in the same file name. So on Linux ARM64 container, we got this output. If you check the final step, then we can see it is basically about generating the release, right? We are going to create some zip file with all binaries, all generated binaries, and then we are going to create the zip file. Then the zip file will be uploaded into new GitHub release, right? Then we are going to notify Discord server as well. That's how the create release step works. But if you check carefully, this create release works depends on several build steps, right? So it will depend on build Linux, build Windows, and build Darwin. So each thing need to be completed to run this create release step. So in each build step, we are using the same command, right, to generate binaries. So if we check the macOS job, here we can find the command. On Windows also, here we can find the command, right? On Windows, we are going to run the script using Python command, right? After that, we can find the same command on Linux job also, right? So here we provide the same command, but internally, according to the CPU architecture and also the operating system, the BuildZri project will generate file names differently, right? So that's how we get binaries in different file names, right, on each operating system and each CPU architecture, right? So if we check the release zip creation step, so this is the step responsible for creating the release zip, so which will be uploaded into GitHub soon. So in here we can see all binaries will be added into zip file, right? Here we have Linux x64 binary and we have Linux ARM64 binary. So those binary file names are generated by BuildZri, right, according to the global variables. So the global variables are very helpful for generating this kind of dynamic file names. So that's how we integrated BuildZri with our CI/CD workflow. So this is basically a CD workflow. So on our CI workflow also you can see BuildZri command. So if you check our CI workflow, which is the test suite, here also to compile the current source code snapshot, we use BuildZri script. On Windows also we use BuildZri script, right? On Darwin also we are going to trigger the BuildZri script, right? So the BuildZri script can be easily used in all CI/CD server. Right now we use BuildZri on GitHub Actions. So that's how you can easily integrate BuildZri with your C++ project and also with CI/CD server workflows. Right now I already explained how you can integrate BuildZri with GitHub Actions. So that's basically about BuildZri. So if you are going to create a new C++ project, you can try adding BuildZri. So it will automate the build process and it will simplify the build automation, right? Unlike CMake, like complex systems, this offers very simple JSON based build configuration, right? It will also work with all popular operating systems like Linux, macOS and Windows. So if we need to get this working on other operating systems like BSD, maybe you can easily port this one, right? In future maybe we can support all operating systems. Right now we support 3 main operating systems, but in the future maybe we can support all the operating systems. Like I mentioned before, you can learn more details about BuildZri from the documentation. Here we explain why the BuildZri project is created. I already explained that, but you can read more details about it. So then you can see highlighted features and how to integrate BuildZri with your project, and with some example projects. Then finally you can see all about global variables and supported CLI arguments, and also all about the configuration file using this reference section. Also you can check the BuildZri source from this link on GitHub, right? You can contribute, and you can add issues if you have some problems. If you have some ideas to improve BuildZri, you can add and issue as well, right? Inside the BuildZri repository you can find one sample project as well, right? So this is the BuildZri configuration, so you can study about this one as well. And this is the BuildZri source file, which you can copy paste into your C++ projects. In the future we will add more features into a BuildZri project to support further about C++ build automation. See you in next video.